This is Algebra 2 with Trig, section 7.4. We're working on logarithms, evaluating logarithms. The logarithm is the inverse of the exponential function. It's found by reflecting the graph of the exponential function across y equals x. So the exponential function is like y equals 2 to the x power. If you reflect that across y equals x, you're going to produce what's called a logarithm. Here's an exponential, for example, like 2 to the x power. Here's a logarithm. These two functions are inverses. The way you read this is to say log base 4 of 16 equals y. That's how you read the notation. Here we have several examples in logarithmic form, and we're going to convert it over to exponential form. You can use this pattern, noticing that the base of the logarithm is the base of the exponential. What the logarithm equals is always the exponent. And then what you're taking the logarithm of is what your exponential equals. So in this case, you have 5 squared equals 25. Some people like to write a little curl across here to show that you start with a 5, then you go to what it equals, then you end with what you're taking the logarithm of. Start with the 5, go to the 2, and end with the 25. 8 to the 0 power equals 1. So we're converting our logarithm into exponential form. You're probably more comfortable with understanding the logarithmic form. You're probably more comfortable understanding the exponential form. The logarithmic form is what we're learning now. Notice how this doesn't have a base. This is called the common log. Your calculator can do the common log. It has a base 10. If it's not written, it means that there's a 10. Just like if you have a number and it doesn't have an exponent, we know that that means 1. Or if it doesn't have a denominator, we know the denominator is 1. The square root has an index. That index is a 2. We don't typically write the 2 for a square root. Just like for a common log, we don't need to write the 10. The 10's the automatic. But now we would start out with 10 to the first power equals 10. ln, that's considered natural log. That's also a key on your calculator. That's the same thing as a logarithm with base e. So that means the exact same thing. But instead of saying loge, we just say ln. That means that the base is e. So the base is e squared, and that's approximately, it's not exactly, it's approximately 7.39. Here, 13 to the first power equals 13. Here the base is a fraction. The exponent is negative. That's okay to have. So the negative, remember, flips over the fraction and then you square it. That's why it says 4. 8 to the x equals y. So that's converting it from logarithmic form to exponential form. So now we're going to evaluate, what is log base 3 of 81? Well, if you can write the 81 with the same base as your logarithm, which would be 3 to the 4th, if you can write it with a 4, really, if you can write it with the same base, then whatever the exponent is the answer. Another way to think about that is 3 to what power equals 81? 3 to the 4th power equals 81. That's what this is saying. 3 to what power equals 81? So the solution is 4. This is saying, this is a common log. You didn't really even need the base 10. 10 to what power equals 0.001? Well, another way to write this is to call it log base 10 of 1 over 1,000, because 0.001 is 1,000th. So we're going to look at this and think about 10 to what power equals 1 over 1,000. Well, I know that uh, 10 to the 3rd equals 1,000. So 10 to the negative 3rd equals 1 over 1,000. The negative puts the 10 into the denominator. The cube makes it 1,000. Here, the base is larger than what you're taking the logarithm of. So that's going to give you a hint that your solution is going to be less than 1. If you think about what you can do with 64, 64 can break down into 8 times 8, which can break down into 2 times 2 times 2, and 2 times 2 times 2. So if you're going to take the 6th root, because there's 6 of them, the 6th root of 64, that does equal 2. The 6th root. So we're going to say 64 to what power equals 2? We know that 64 to the 1/6 power, because that's the 6th root. That equals 2. That means your solution is 1/6. Here we have 1/4. It says 1/4 to what power equals 256. Well, we know that the exponent has to be negative because you've got to flip the fraction up to become a whole number. And then 4 to the 4th power is going to be 256. So 1/4 to the negative 4th is going to be 256. So your solution for this, or to evaluate it, would be -4. On the next page, you should take some time on your own and try to evaluate many of these. So you can pause it now. Try to evaluate the best you can, and then I'll go through and show you some methods for calculating it. Don't use a calculator. Just evaluate it without. Here we're looking at 5 to what power equals 1. You might like to say equals x, because that's what we're trying to figure out. What does this equal? Well, 5 to what power equals 1? Anything to the 0 power equals 1. This is a common log with a base of 10. So 10 to what power equals 100? That's what it's being asked. So we know that it's 2. (49) to what power equals 7? Well, there's a couple different ways for us to think about this. I know that if I square 7, I get 49. But I don't want to make the 7 bigger. Squaring, so a way to get rid of the square is to do 1/2. So 1/2 of 49, not half of 49, but 49 to the half power is 7. So if you take the square root of 49, you would get 7. The exponent that represents taking the square root, or radical, is 1/2. So 2 to what power is going to equal 1 over 32? Well, I know that my exponent has to be negative because I'm making a fraction. And I know that 2 to the 5th power equals 32. So I know that this has to be -5. (5 to what power equals 1 over 125? Well, a negative is going to make it become a fraction. 5 to the 3rd power equals 125. So -3 is what x would need to be for 5 to the -3rd power to equal 1 over 125. Again, sometimes we like to think about the curl, which is 5 to the x power equals 625. So we're trying to evaluate 5 to what power? There are ways to use your calculator with this, but you can't just type in the normal log button. That's the common log, which is base 10, so that's not going to work. You've got to think about what times what times what is going to make 625. There's a couple ways you could do it. You could just take 625 itself and start breaking it down. 625 is 25 times 25. I know that that's 625. 25 and 25 is made up of 5 times 5 and 5 times 5. So I know that 5 to the 4th power makes 625. So my x, or my evaluating, would have to be 4. (1/3) to what power equals 9? You would have to have a negative exponent, and then that would turn this into a 3, and then if you squared it, you could get 9. So -3, 1/3, not -3, -2, 1/3 to the -2 power would give you 9. 16 to what power equals 4? Well, I know I have to go smaller. So I know that this is even going to be less than 1, so it has to be a fraction. What can I do? What type of radical do I need to use to break down 16 to become 4s? If you take the square root of 16, you get 4. So the exponent that represents a square root is a half. Okay, these are some special logarithm values that you want to be very familiar with. Regardless of what you're taking the logarithm of, well, regardless of what the base is, if the logarithm is of 1, then you know that it has to equal 0. Any number to 0 power is going to equal 1. If your base of your logarithm equals the base of what you're taking the logarithm of, then it's going to equal the exponent. So if these two numbers are exactly the same and the exponent's a 1, then your answer's a 1. If it's a 2, then your answer's a 2. It's whatever the exponent is. A common log will have a base of 10. That's the same thing as if it's not written. If it's not written, it means that it's a base of 10. If you have ln, that means it's a base of e. Now we're going to evaluate several of these using a calculator. So the log button is right next to the 7. 2.3. So what this is saying is the base of 10, because there's no base written there, so remember this is called the common log. 10 to what power equals 2.3? 10 to the first power equals 10, so you know the answer is even less than 1. So this is 10 to the 0.36 would equal 2.3. So the logarithm of 2.3 is 0.36. Natural log of 0.2. E to what power equals 0.2? You definitely know that it's less than 1 because e to the first power is going to be 2.718. Now if it was e to the 0 power, you know your answer would be 1. So you know that this is even going to be less than the value of 1 or of 0, less than 0. Negative 1.61. The natural log of 222. So that's saying e to what power equals 222. 5.4. E to the 5.4 power is going to be about 222. Okay, now these can be a little tricky to understand. Okay, we've talked about in the past about the exponential. Now we've been talking about logarithmic, and they are been known to be inverses of each other. So that means if you do f of g of x, we've done this before, where you take your g function and you plug it in for your f function. You know if these are actually inverses of each other, you should get x. In other words, if you have a base, this is an exponential, you have a base that matches the base of the logarithm, then your answer is whatever you're taking the logarithm of. So in this case, the 10 is the base of the exponential. It's not written here, so you know that the 10 is the base of the logarithm. So you know the answer is 6.7. Same idea here. You know that the exponential base is e. You know that the logarithm base, because it's ln, it's e. So they match. So the answer is 9. Exponential again. Exponential base is 8. You know the logarithm base is 8. So your answer is what you're taking the logarithm of. In this case, it's 9. Here we have logarithm. This is the first example here that we're dealing with the logarithm of a number. So if you do g of f of x, that means you take the f function and you plug it into the g function. So you're going to have log base b of f of x. Well, f of x is b to the x power. So if your logarithm base equals the base of what you're trying to take it of, then the exponent is the answer. We talked about that earlier. So the 7's match, so you know the exponent of that is going to be negative 3x. This one's a little trickier because the exponents are not matching. I'm sorry, the bases. The bases are not matching. This one has a base of 2. 16 doesn't have the same base. But can we make it have the same base? So 2 to the 4th power is 16. So I haven't changed the problem at all. And you multiply exponents if you're raising a power to the power. So now the bases match, and my answer is 4x. Here, 27 is not the same base as 3. The question is, can we make it have the same base as 3? Three to the 3rd is 27. So we know the answer is 3x. And the same problem we did earlier, log base 2 of 2 to the 4th, and then you would multiply the exponents, so you get 4x.